Hi, everybody. Welcome to the Energy Storage Market Series. We're going to go ahead and let everybody kind of filter in here until we get kind of a stable number. And then I'll go ahead and kick it over to Jay. In the beginning here, while we're just kind of waiting for everybody to filter in, I'm going to go ahead and just talk a little bit about RENVU in case you haven't. This is your first time joining us, you haven't heard too much about us or know some of the products and services we offer. My name's Nick. I'm a sales engineer here at RENVU. Give you a little bit of background. RENVU was founded in 2012 and based in Mountain View, California. But we have fulfillment centers on the West and East Coast as well as in Texas. Our entire sales team has an engineering background, which allows us to go in depth on projects with our customers, whether it be small DIY projects up to larger commercial. Kind of jumping forward here, some of the services we offer. Megawatt Club is a really great program that we offer that gives you, for a small membership fee, free shipping on all orders in the continental US, as well as discounts on permitting services, some extra perks during promotions that we're offering. As well, like I mentioned, we offer engineering services and permit packages from anything, again, small residential up to larger commercial. We have an online quote and design tool called the SKG, the Solar Kit Guide. We also have a number of other ones. I'll kind of touch a little bit on that at the end of the presentation after Jay's been able to talk a little. And we offer a number of different financing options, both for end users and installers to help with different projects. So we'll talk a little bit more just about some of the products we carry before kicking it over to Jay. First on the list here is PowerField. It's a really great simple solution for ballasted ground mount applications. So it's a little bit different than your standard pole mounted ground mount application. KB racking, another great racking solution, ballasted racking option for the roof. It's incredibly fast and easy to install, and it's at a really great price point that keeps it pretty competitive. We've had webinars with both of those not too far in the past, so you can always take a look at our YouTube page to find those previous ones. Enphase, I'm sure most of you all know about Enphase, but great, reliable, everybody in the United States is using it. Very simple. We've got their storage system up and running now as well as an added option. So let us know if you're interested in that. NLX, recent addition, it's a EV charger, step 2 48 amp EV charger. We have options for both residential and commercial available, as well as higher current options for the commercial chargers. Trina Solar primary module we have right now, 395 watt, 60 cell, really great module, high power density, and looks really nice. Last is Blicker, which is a residential carport solution. After we're done with the presentation, I'll go ahead and talk a little bit more about that before we jump into a Q&A section. Just a couple other things to mention before we get joined by Jay to talk a little bit about Iguana. If you do have questions about any of these products or Iguana as we're going through, please feel free to use the Q&A section. We prefer that to the chat because it makes it a little easier to keep track of questions and answer them. And we'll get to those at the end when we jump into the Q&A portion of the presentation. That's it for me right now. I'll go ahead and thank Jay for joining us, and I'm going to go ahead and stop sharing my screen here, and then Jay, I'll go ahead and let you take over, and we'll go from there.
Okay, sounds good. Thank you, Nick. I appreciate the intro. Excited for this new partnership, and to everyone on today's call, my apologies for sort of like, it's a little bit of an impromptu thing. I normally do this in kind of a closed environment, but this is going to be new for me a little bit, but excited to present it as well. So let me get my screen on here, and there we go. Okay. So as far as the Iguana battery energy storage system, it is a lithium ion AC coupled battery energy storage system. Makes it great for the retrofit market as well as for new PV plus battery installations.
Not to cut you off, Jay, but if you've got your slides pulled up, I don't think they're shared yet on the.
Oh, really? Oh,
yeah.
Oh, shoot! I thought I did.
There we go. Okay, cool.
There we go. Okay.
Sorry about that.
Yep. No, thanks for the heads up. I'll take all the help I can get sometimes. Thanks. Again, so the Iguana Evolve is an AC coupled battery energy storage system. It's a lithium ion based product, either with the NMC battery modules, as shown in the Evolve ESS version of that product, and as well as with an LFP module based model. All of the information that I'm going to be sharing today is taken straight from our product resources that we have on the web page. If anyone would like to see what that is, you can easily follow along or take a look at your own leisure at eguanatech.com and go to products and look at the North American Evolve product. There are a list of resources at the bottom of the page for the Evolve Hub, as well as for the individual battery products themselves. So I'll leave that up to you to follow along, and we'll go ahead and just proceed here. So a lot of benefits, a lot of good information here. I'm just going to go ahead and start with the slide deck itself. But before I do, just to show you a quick photo of a sample standard installation. There it is. This is the Evolve ESS with the Evolve Hub installed with a gutter and required disconnect. This is probably one of the simplest manifestations of the product on a wall. It's pretty simple, pretty clean cut. So let me maximize this guy here so we can all have that. Okay, and my email contact information is shown here in the bottom left. If anyone has any follow-up outside of the RENVU normal channels, if you've got a specific design or question regarding the resources that I've referenced here, just let me know and I'll be glad to help you with that. As far as the product training itself, it's usually split into a couple of different parts. This session is going to cover with the classroom portion, and then there is commissioning training, which is scheduled one-on-one. We're looking at Iguana is a pretty rapidly growing company. What we've been doing up until now has been doing in-person, on-site commissioning training. We're looking at expanding our market footprint as far as boots on the ground, as well as increasing our online training resources for like video guides and stuff like that. But for right now, we are still scheduling the one-on-one commissioning training to supplement the classroom or webinar version that I'm going to do today. So what I'm doing today, I'm going to cover the product introduction, features and functions by component. We'll look at design considerations for solar plus storage, both at the product and system level. We'll look at some brief installation considerations, and then startup and system commissioning. Some basic technology definitions that are referred to in this deck of slides. Some of them you may be familiar with, some of them may be new to you. Just a quick read through here. BESS, battery energy storage system, pretty self-explanatory. PCS is a power control system. It's one of the components within our battery system. It's just basically the electronics, the inverter and power electronics. The BMS is a battery management system. It's integrated into the battery modules themselves from the battery module manufacturers. Each battery has its own BMS, and they are all connected through internally through the inverter and our control and monitoring system to make sure that the system always operates, within safe bounds. The EMC, or the Energy Management Controller, is basically the gateway communications and control device. EMS is the Energy Management System, the overall, includes the Energy Management Controller and the switching circuitry within that smaller enclosure, the EMS, the Evolve Hub. PV, obviously photovoltaic, ATS, automatic transfer switch, SLD. You guys pretty familiar with that, I'm sure. Single line diagram. PKI is public key infrastructure. It's just basically the naming convention used for our security certificate that's required for a field laptop to commission these systems, so that because edge of grid resources will and are moving towards aggregated network applications, the control and access to those devices, once utility programs have been subscribed to, will come with a high level of security, and making changes to configurations in these systems needs to be kind of locked down. So that's what we use for that. CT, obviously current transformer. SOC, pretty simple, state of charge. UID is user identifier for the EMC itself. It's sort of like a MAC address or a serial number. The ECI is the Iguana Communications Interface. Not really necessary for installation or commissioning, but just be familiar with it as it might be mentioned. It's the second level field troubleshooting and control tool that is available to installers. ARC's auto recovery mode. We'll get into a little detail on that in the coming slides. For systems where multiple thresholds, lower SOC thresholds have been exceeded, if the batteries go into sleep or hibernation mode, or even further into a critical low SOC and shut down completely, rather than having to deinstall the battery, ship it off somewhere to have it recovered, or to have any special external charging equipment to recover those battery modules, the system will do an auto recovery of any depleted battery modules. If they can be recovered, it'll use the grid voltage to do that. So it has an auto recovery mode, which is really helpful in cases where it's needed. PDU is just a power distribution unit. It's just a metering function on the EMC. Okay, real quick introduction. We'll be looking at the Evolve system components, system architecture for AC coupling, solar plus storage. We'll look at ATS and EMC functions, as well as the PCS architecture, basically just the system layout. We'll look at battery architecture within the battery cabinet, the connections in there for both DC conductors as well as communications. And then touching a little bit on the LFP battery highlights, some of the features and benefits of the LFP based battery module. And then of course, battery system protection functions. We'll touch a little bit on that too. So again, as I mentioned before, all of these the references, the graphics that I'm going to use throughout this presentation can be found on our published resources for the Evolve product. And this is the website here. I'll be taking some graphics and information out of the Evolve Hub installation manual. That's the gateway or hub, includes the EMC and the ATS circuitry, and as well as the battery, either the Evolve LFP or ESS installation and startup manuals. And then there's also a really nice 2-page wiring and commissioning quick guide that's super helpful too. All right, a quick overview of the basic components or building blocks of the system overall. It comprises of the monitoring, which is the consumer user interface or the consumer monitor, as shown in this picture here. There's no app for like a smartphone, but the design of the web UI is such that the blocks of the display will reorient themselves based on the aspect ratio of the device that the customer is looking at. So whether it's a a desktop or a tablet or even a smartphone, those blocks will reorient themselves and the display will be on the same, just oriented slightly different. Monitoring system also consists of the installer user interface. So the installer use that to onboard and remotely monitor as well as remotely change configurations for their network of installed devices. It also includes some fleet aggregator tools as well as I just mentioned, account administration and remote configurability. The EMS system, the Evolve Hub, performs the functions of energy management and cloud reporting. It's got some parallel cloud communication pathways on there. There's PV and load curtailment controls. Actually, the PV curtailment controls are not included on the Evolve Hub. This is the legacy enclosure here that has a PV curtailment, but that's really not necessary for the mainland US. This is used more in Hawaii. There's also battery control via Modbus serial connection. It also handles system fault handling and reporting. And again, it houses the automatic transfer switch circuit as well. As far as the battery system itself is concerned, it consists of two basic systems. One is components or subsystems within the battery. One is the PCS, the power control system, which is basically the inverter and the power electronics, transformers, stuff like that. The battery, it acts as a battery gateway or a bridge to AC grid and AC loads, and it ensures a safe operation of the battery and inverter. It's rated at 5 kVA or 5 kW in power. So while grid tied, it will only charge or discharge up to 5 kW, but in off-grid mode does have some surge capability in discharging. It will go up to 120, and this is again listed on the product resources. You can find this information on the data sheet online. It'll surge up to 120% of nameplate or 25 amps or 6 kW for up to 30 minutes, and will surge up to 170% of nameplate or 8.5 kW or 35 amps for up to 5 seconds. And then the DC component or the DC cabinets basically just consist of the battery modules themselves and their BMSs. The BMS ensures a safe operation of each of the battery modules, as well as there being a battery disconnect inside the first battery cabinet. For the LFP systems, the capacity ranges from a minimum of 14 kWh up to a maximum of 42 kWh. And for the NMC-based product, it goes from 13 to 39 kWh. A quick look at some of the features of the PylonTech LFP battery module. The LFP chemistry basically is considered to be non-toxic, non-polluting, and more environmentally friendly than the NMC chemistry. The protection functions included are over discharge, overcharge, overcurrent, kind of basic stuff. Does have a flexible configuration where multiple battery modules can be connected in parallel to extend the capacity and power. So you could start off with a 14 kWh system, for example, for your customers, and a year down the road, customer says that they want to have a larger capacity system, that you could easily bolt on extra storage capacity, make that bucket bigger without having to add any more inverters to it, or probably in most cases, permitting requirements would be negligible. Don't quote me on that, check with your local AHJs, but just adding extra capacity doesn't change the power component or any of the interconnection requirements. So it makes it easily expandable. It has a self-cooling mode with reduced system noise. The module has less self-discharge and up to 6 months without charging. As far as the performance and temperature range, operating temperature range, it's from -10 degrees C to 50 degrees C, with the charging and discharging ranges shown here. It has a 6,000 cycle life, 10-year warranty, but is expected to operate for 15, potentially more years. on top of that. Not on top of that, I mean, like, in addition to the 10-year warranty, it's expected to run for at least another 5 years or more after that. Okay, so a quick intro. Some of this may be very basic to many of you. Some of it may be new, but just to set the foundation. An introduction to AC coupling solar plus storage. It basically means that the PV, the loads, and the battery itself are all parallel connected to the home load center. Makes it ideal for retrofit, where you've got customers who already have PV. You can go back to those customers and offer them a battery storage option for backup, time of use, etc., without having to make very many changes to the system using the same PV inverters. And a pretty critical point to make here is that because it is AC coupled, there is no PV module DC input to the battery. All of your PV must have its own dedicated either microinverter or string inverter. The PV inverter must be supplied. Another quick look here as far as AC coupling, solar, and storage. It's based, the control and the operation is based on the EMS, the energy management system. The energy flow is managed by the EMS panel or the Evolve hub. The way that we do that is it's pretty basic, and we measure, take some CT measurements, primarily at the main electrical panel, at the point of common coupling, at the service panel near the meter, and measure import export. We also measure PV production, and a quick add or subtract. The difference between PV production and import export either tells us that there's an excess of loads or an excess of PV production. And then we tell the battery to either charge or discharge and monitor that charge or discharge from the battery CTs. In slightly more detail here, that energy algorithm for solar self-consumption, the battery is told to charge whenever solar is greater than loads, and battery is told to discharge whenever solar is less than loads. Any excess PV is exported to the grid. It's pretty simple, and it probably not new to most of you. And as far as net zero is concerned, that's what our basic sort of assumption is, that we're trying to maintain net zero at the meter and provide the most value to the customer, especially when they're using time of use rates with the utility, where they can save, produce power during the day and use it when rates are higher during peak load time at night. Quick look at the system architecture for the AC battery plus the Evolve hub. Looking at the EMC and ATS here. This is, again, one of the graphics taken out of the installation manual. And is a basic, this is from the conduit plan graphic, I think, in the Evolve hub. And so this shows the layout and the interconnections, the association between the Evolve hub, which actually is sort of central as a hub component. It's a UL 1741, and this is actually a good point to note here, is that one of the best sort of value add features of that Evolve hub is that, for example, in a situation where you've got a service panel with a 200 amp main and you've got a PV already installed, 7,600 watts, maximum 40 amp backfeed circuit going into that service panel. If you want to add another grid side inverter per the NEC, you would have to, with that the interconnection rules of the NEC, you would have to either derate the main in order to add more backfed breakers to the same 200 amp panel. You would have to either derate that main or upgrade the service. In the case of our system with the Evolve hub as a UL 1741 certified interconnection device, you can use that same 40 amp interconnection that original PV was using and route it through the hub. Again, you would have a dedicated backup load sub panel. The PV would be landed on there, and then the hub would have that 40 amp interconnection where even if the PV was off, you would still use that PV backfed interconnection. When loads were low, you backfeed into the service panel to feed other loads in the home. And then by routing this other grid tied, in effect, another grid tied inverter, the battery system itself through the hub, what we're doing is we're regulating through this certified interconnection device the discharge of that battery based on what the real-time PV production is, so that the combination of the PV inverter plus the battery inverter never exceeds the backfeed rating of that breaker. So you can, in effect, close to double your time of the day that you have available generator, renewable energy generation sources. More details on that you can see in the Evolve Hub manual, but it's one of I think probably one of the most important features of the Evolve Hub setup is the ability to bypass the extra cost to your customers and time of installation and ease of design using the Evolve Hub setup. Disconnects shown here are standard NEC requirements. Won't get too much into that. Battery architecture, I won't get too much into the details here, but just to kind of note that there are specific diagrams within the manual that will guide you for installing very specific layout for the DC conductors as well as the communications cabling for the LFP modules. So some built-in PCS battery protection functions. As I mentioned a little earlier, there is an auto recovery feature where if the batteries go into hibernation mode, when dropping below a critical minimum SOC, that the PCS has controls to take the battery out of hibernation, and that there's no need for external battery charging equipment. This note here to not turn the battery turn on from the module power switch. This is just a side note that for people who are service oriented, if the batteries have been shut down, that you don't need to turn them on from the battery module switch, that the auto recovery feature will turn the batteries on automatically. So there's also a battery maintenance routine, as with most systems, most PV plus battery systems. The battery modules within the system are kept balanced within a few percent of each other. If any battery module SOC versus the battery rack SOC is greater than a 3% delta, it'll kick in that balancing routine. And there is a pre-charge circuit in the PCS, prevents high inrush currents to the bulk capacitors. Don't want to really get too much into this. This is a little bit of a side note, but important, as a service note, if you have to turn the battery system off using the DC breaker, there's another slide later on that kind of goes into a little bit of that. So system design considerations, and this is actually, I think, a really good sort of dovetail in some of the services that RENVU offers as far as their planning or engineering services that they may be able to help. A lot of installers seem to take a lot of time on some of these preliminary planning and design stages. And I think that for those of you who may choose to take the RENVU services as a part of your battery installation program, some of this may be taken care of by RENVU. But as a review anyways, what we're going to cover here is PV to battery system ratios, breaker sizing, and backup power, some of the battery capacity sizing based on the nominal load, the PCS output power limitations for inrush and transient performance, typical home load profile examples, notable home load cases, and really importantly, backup load panel planning. And if you are going to be, and you should be planning that backup loads panel, what type of equipment would you need to measure total black start load profile? So your backup loads panel all of the loads that you plan on putting on there, you should measure them to know what the inrush characteristics are, what types of loads they are, and what potential effect they may have on the voltage waveform. Most importantly, when in backup mode, because you want to make sure that you don't overload the battery system, especially when there's no PV. Overnight, your loads need to be served by the battery, and then obviously last through the night till the sun comes up the next morning and the PV kicks back on. And so you want to make sure that there's seamless performance, and you don't overload the battery and cause any nuisance trips during a grid outage. Then we'll also look at a single line diagram review for AC coupled solar plus storage. And moving right along, just real quick, PV inverter to battery inverter ratios. As a general rule, it should be 1-to-1. This allows the battery to absorb peak PV current until the battery is full. And that's assuming that there are no off-grid loads. And this is also in backup mode. The battery charge is limited to 5 kW. Again, it's a 5 kW inverter. So excess PV or that charge current needs to be limited to a maximum so as to not trip the battery system offline. The battery discharge has limited surge capability up to a maximum of 8.5 kW for 5 seconds. As far as the sizing, that general rule of 1-to-1, that is the by the book answer. That is because peak PV current the peak excess PV current needs to be below 5 kW. In applications, it can, as this little note says here, it can, with some caution, the AC nameplate can be oversized to a maximum of maybe approximately 6 kW, 5,800 watts, based on array orientation, time of day, and baseline loads. You can pretty safely assume that excess PV is going to be less than 5 kW at any point. So with some caution, I think a little bit of fudge factor can be taken into account here. And then in cases where the PV inverter to battery inverter ratio exceeds 1-to-1, say for example, you've got 10 kW worth of PV, you've got 2 5 kW string inverters, that PV needs to be split up, where one would be connected directly to the backup electrical loads panel, and the other would be connected in parallel to the battery system at the service panel. And this, of course, is in interconnection agreements where export to the grid is allowed. And this is an energy management exercise. Basically, there are a couple of different sizing considerations that can be taken into account, as explained in the Evolve Hub manual. The maximum grid-tied PV production is 7.6 kW onto the backup loads panel for this 40 amp interconnection. That maximum is while grid tied. So when off grid, when the system goes to off grid mode, that excess PV needs to be limited to 5 kW. And the only case that I know of that a PV inverter will allow third-party external control to derate that PV from 7600 down to 5 kW or somewhere near there is the SolarEdge string inverters. They have a PRI, a power reduction interface, that allows for a simple DC control loop for us to, operate a relay in our battery system to change that 7600 watt inverter down to 5 kW. So that's a really convenient method of maximizing your PV sizing on the isolated portion of the system that would be operational during backup mode. But other than that, like say, for example, if you had 7600 watts of N-phase microinverters, you would have to split that up because N-phase and other PV inverter manufacturers don't allow external control of their output. So keep that in mind all across the board. So just a quick review, backup power. the Evolve system is rated for emergency backup power only. It's not intended for off-grid use only. Black start capable for both loads and solar PV. That means that it goes from being a current source synced to the grid voltage while grid tied to being a voltage source when the grid goes out. And that voltage source will, of course, serve the backup loads as well as provide a synchronizing voltage to the solar PV to produce an off-grid mode. Whole home backup is not possible without load management, and really is sort of a thorn in most people's side. Whole home backup to me, I think, is more of a fiction. If you've got to turn off loads when you go to backup mode, that's not the whole home. But anyway, the interconnection of our system and the design architecture really excludes whole home backup or the use of load control panels in the event that a customer wants to have the entire panel selectable. So some design considerations that differentiate our product from others. Really what we try to promote is management of expectations. And when your customers experience a grid outage and for some reason the battery is tripping offline because there are too many loads on it, you instantly become the utility, and answering phone calls and having to go back to explain to customers why a battery is tripped offline is really problematic and probably outside of your best business case. So managing expectations and building a backup loads panel with essential loads in the off chance that the grid goes down. How often does the grid go down and for how long? In most cases, usually it's short duration. Most cases not longer than a few days, and essentially you want to keep the food cold, keep the lights on, and ability to communicate and survive comfortably without the grid voltage. So anyways, management of expectations. So as an exercise, question here is, what capacity would you reserve for emergency backup power? Well, it depends. How long are your outages and what size are the loads? Just a quick review of what's listed on the data sheet on our website for the Evolve. The inverter has some limits for different types of voltage, performance. So for continuous power, as far as load serving loads, continuous power again is 5 kW or 5 kVA. 20.8 amps on each phase, so it's 2.5 kVA on each phase. So the backup loads panel needs to be balanced. That's a pretty basic assumption, but needs to be mentioned. It has a surge rating of maximum of 5 seconds at 170% of nameplate. And again, that's 8.5 kVA at 240 volts, and you can do the math here. And then it will also withstand transient peaks of 8 amps for 100 microseconds. So won't get into too much detail here, but we will look at how to measure these loads and what types of loads fall into what categories. Typical home loads, for example, this toaster oven would be a continuous power requirement. Any resistive load is a purely continuous load and is pretty easily accounted for. Other types of loads that would have inrush characteristics, as shown in this yellow circle, motor loads, for example, or anything that would have a sort of a combination of the continuous as well as inrush characteristics, like a refrigerator that would hum along at a certain power level and then surge when the compressor kicks on. Would be sort of in the middle here. And that surge rating is really the peak that you're looking to plan your backup loads panel for. And it is very important when it comes to system planning, is that backup loads panel planning. And so that you want to reduce your service calls, make sure that your customers are always happy. And then when it comes to transient peak performance or voltage effects on the voltage waveform, fluorescent lights, CFLs, things like that, and gas ignited lighting, as well as some switch mode power supplies might have transient spikes on the voltage waveform. A lot of consumer electronics, those switch mode power supplies, will have characteristics that sort of blend in the intersection between continuous loads and transient spikes on the voltage waveform. And while the transients can't be accounted for in all cases, they can be accounted for in some cases up to a certain degree and filtered out. And my suggestion is to installers who have customers, if you have a home office, especially with like a laser printer, a lot of consumer electronics, like all of this stuff here, those things can be put on a UPS. You get one for $150 to $200. The basic home floor mount UPS will filter out all those transient voltage spikes and protect the battery, the big battery, from having any nuisance trips, as well as provide the added function or added benefit of protecting these loads from the 4-second transition from grid side to off-grid mode. There's a 4-second delay when the grid goes down before the battery will kick in backup mode. Quick example of what you might see on during backup load planning, or actually what you could see if you had a field O-scope. But I think the point of this slide is to show that although the manufacturer's nameplate may show that its surge rating is 3 times continuous, it can, whether serviceability of the equipment, how old it is, et cetera, it may actually surge quite a bit higher. So measuring the loads is ultimately important, even more important than jotting down manufacturer nameplate ratings. So measuring those loads is really important. Can't stress that enough. And the type of equipment that you use to measure those loads is really important too, because you might not always see it. You definitely won't see it with a standard RMS ammeter, especially these transients as shown here. And again, there may be quite an effect on the voltage waveform based on the types of loads that you may not be able to measure with the standard ammeter. So how would you measure those things? When backup loads planning is a big part of installing a battery system, the Evolve especially, standard ammeter will measure those continuous loads. And so continuous current can be measured with most, any ammeter. But also pretty common in a lot of ammeters that are available now is inrush detection. And what that does is it has a max hold for that peak current when you turn on a motor, when that compressor cycles, when you open the refrigerator door. So highly recommend having an ammeter with inrush detection and learning how to use it. It's pretty simple and will definitely pay dividends. Don't expect that anyone will buy or would not even recommend that everyone buy a field O-scope to measure transient voltages. Really what I would do is I would just try to avoid big banks of fluorescent lights and any home offices, especially with like laser printers, a lot of switch mode power supply consumer electronics, maybe put those behind a small UPS to, again, avoid nuisance trips of the battery when in off-grid mode. So backup power summary. The backup power system is rated for 5 kW continuous. Black start of PV and all loads must take into account all limits, continuous, surge, and peak transient, because if those loads exceed the limits stated for the product, when grid goes down, customers who are expecting backup performance might just be tripping the battery off each time it tries to go into backup mode because there's an excess of loads on that backup loads panel. Again, surge ratings listed here and on the data sheet, spec sheet. And the home load profile may constrain the backup power limits due to a high quantity of nonlinear loads. So say, for example, you've got a refrigerator that might operate at 200 watts, but surges up to 1800 watts when that compressor kicks in and you've measured it. And you've got a microwave that operates at 1000 watts maximum that might cycle on and off. You want to make sure that you put that microwave on line 2 if the refrigerators on line 1, because you want to make sure that you don't exceed the max current on the inrush side of things. You obviously want to balance the loads, especially for nonlinear loads. So that's the planning stages. That's the first big step in success with the battery products. Next is the installation. Installation is actually pretty simple when you follow the guidelines listed in or laid out in the installation manual, other resources that we've got on the website. This is a basic single line diagram template. Again, this is taken from the Evolve Hub manual. This I won't get into too much detail here, but this is basically just a single line diagram version of the conduit plan or block diagram that I showed earlier, where the main panel in this case again is a 200 amp panel with the maxed out 40 amp backfeed breaker, backup power sub panel, the PV being landed at that backup power sub panel, and the Evolve Hub, and this shows the switching, basically the ATS functionality within the Evolve Hub for when grid tied versus when in off-grid mode, or if the battery's in offline or taken into, before it's commissioned and turned on. This will route that same backup power sub panel to the service panel. So pretty good amount of flexibility and a lot of pretty easy to install, pretty basic here. So some considerations for installation. Now, some of these are pretty basic and but pretty important too. So environmental, of course, you want to make sure that the battery location doesn't exceed the environmental considerations that are listed here, especially the temperature. If you're installing it up on top of a mountain and it's really cold up there, you might want to consider putting it inside the garage if it's heated. The product is NEMA 3R, so it's outdoor rated, but it's also indoor approved. Obviously, do not install in direct sunlight because ambient temperatures inside the cabinet may exceed external temperatures just because it's an aluminum cabinet. In direct sunlight, the internal temperatures will be hotter than ambient temperatures outside. So the battery cabinet itself is convection cooling only, but the PCS cabinet does have active cooling. There are a couple of fans in there. Structural considerations for installation, because it's a wall-mounted system only, the structure that you're mounting it to must be load supporting. So details on that are listed in the battery installation manuals themselves, but it's really not too much of a concern. The load is distributed over a pretty large mounting bracket with multiple attachment points, so that I think that a basic system distributed load, each anchor bolt that goes through the bracket really only supports about 60 pounds itself. So that's distributed over several different mounting points. Wiring considerations for installation. In addition to the AC conductors, there are CTs that you've got to wire between the hub and obviously the service panel, the battery itself, and the PV, which is internal to the hub. But if those CTs need to be extended, you've got to make sure that you use the right spec wire and account for that. The Evolve Hub, the backup load control, relies on the AK1 relay connection in the PCS, and this is a kind of a minor detail that's covered in the installation manual. But besides, just listed here as a note, to be aware of, in addition to standard conductors, this conductor as well as the battery communications cable, these are all provided with the system. And so as long as you adhere to the spacing guidelines that are shown in the manual as far as how close the EMS enclosure needs to be to the battery cabinet, then all of the provided cables will work as is and won't need to be extended. The CTs are probably the primary thing that you, in most cases, will have to extend. or have the highest likelihood of needing to extend. So make sure that you use the right spec and type of crimps, no wire nuts on CTs and stuff like that. And of course, pay close attention to the battery module connection. The communications cabling especially is pretty specific. You know, there's an input port and an output port for communications, and just a little bit of attention to detail will pay dividends in avoiding headaches. All right, another view of that block diagram with the conduit schedule on here. I won't get into too much detail on this again, but just to note, the CT pigtails on the CTs that come with each system are 8 feet. And while they can be extended, they can be extended up to a maximum of 500 feet with the right spec cable or wire. So these little details are taken from the wiring and commissioning quick guide. It's a 2-page guide that is a good reference to have on hand, either on your phone or maybe a printed and laminated copy in each truck, you know, whatever. After you've installed a bunch of these, it's good to have, you know, maybe on hand just as a reminder to your installers when they're in the field. It's laid out in a color-coded, kind of focused way. The details for each connection are shown here. So for example, what these arrows are pointing to are inside the PCS cabinet. So this is the PCS cabinet because it's got the lights on it. So the detail has a little circle, and inside that circle shows where these conductors are that you would then place the CTs onto. And the triangles show the arrows noting the direction that the CTs need to be oriented, as an example there. And the second page of that quick guide are the commissioning steps, and those are laid out here as well. Just wanted to show that as one of your available resources. And that's it for that's the installation. At this point, it's just a matter of turning everything on and commissioning it. So then at that point, you would turn on the battery modules with these toggle switches, and then press the there's a button, an SW button on the master module, and that'll power on all of the modules in the rack. Once the DC side is on, just like with string inverter, DC first and then the AC. Once it's powered up, it has a grid timer, grid voltage timer, standard IEEE timer, 5 minutes, and the battery will then grid connect. Once it's connected, then you would commission the system. You connect. What we're going to cover here, or look very briefly at, is some of the commissioning steps, the prerequisites, pre-commissioning, and then the actual commissioning itself. As a prerequisite, you're going to need a laptop with a web browser on it. Obviously, we recommend Chrome. Firefox also works. It does not work with Internet Explorer, and so recommend Chrome as the browser that you use. Obviously, you'd need an internet connection to set the system up, as well as have it connected for continuous monitoring. There's a 90-degree mini USB that's included with each system to connect your laptop to the controller, to the EMC, and configure it to commission the system. The PKI certificate, again, is a security certificate that you will issue from your installer admin account to your installer field laptops, to those devices. Those pre-commissioning steps, one time only, and it's specific to each laptop. Sort of an administrative step here. You would log in and you would get that PKI certificate. Those PKI certificates are good for a year, so you've got to do it once every year. Once the system is turned on, the EMC connects to the cloud. That cloud connection, it will then download the list of PKI certificates or approved installers that are allowed to access it and do the commissioning. So again, during commissioning, you want to follow the quick guide. The quick guide shows you all the steps for commissioning, and it will be covered in detail during the commissioning training. As far as your first step, you've got to record the UID and all of the customer information, the customer's utility, their address, customer's email for monitoring access. And then you would go in and configure the gateway or the EMC itself, record set it up for whether it's self-supply or time of use, the energy algorithm, and then a couple of the other settings, configure the CTs. There's a guided configuration where the CTs are automatically detected. So it makes it pretty easy to identify any phase wiring issues, or if CTs are oriented the wrong way or anything like that. It's very self-guided, and it's pretty easy. I know it's kind of a lot, but that's it. Once, I may have covered a lot, but I think with a little bit of attention to the online resources, and once you go through the commissioning training, you'll find that these systems are actually pretty easy to install and can be installed pretty quickly too. So that's it. That's the end of my presentation. I think at this point I want to pivot to some questions. I see that there are some questions that are in here. Before I jump to those questions, though, I will be glad to answer them all. I want to kick it over to the RENVU team and see if anyone has anything to add at this point before we go to the Q&A.
Hey Jay, thanks again for running through all that. I had a lot of great information. If you don't mind, I'll actually jump in and just talk about Blicker, that carport solution real quick, which we actually pair with Iguana for a storage solution and a couple of the variations of it. But let me go ahead and get that pulled up. If you wouldn't mind just dropping off.
Oh yeah, let me
share
stop.
The screen real quick. Yeah,
yep.
No problem.
There you go. Thanks.
And then I'll just do a quick overview, and then we can start jumping into that list of questions. Okay, let me jump forward here. Okay, so Blicker, like I was mentioning earlier, is a residential carport solution that we've started offering. It's got a lot of sort of great features that we weren't seeing out in the market until we had it available. So I'm just gonna jump in here real quick and go from there. So it's made in the USA, manufactured out of Texas. Really great manufacturing facility. Comes with a 25-year standard warranty. Incredibly sturdy design. I believe is going up to 175 now, actually, mile per hour wind load, with 35 pounds per square foot snow load. That can be increased in other designs. Incredibly easy installation. Is designed in a way to make it so that you don't need any heavy equipment for the install. Pier depth only goes 2 feet into the ground. The components are set up with braces to be able to ship easily in smaller components and then piece together on the job site. It's 18 by 18 by 9 feet. So it's an 18 by 18 foot square. It fits 2 cars comfortably and sits at a 5-degree tilt to allow for shedding and of rain and snow and get a little bit of that angle optimization. Moving on. We offer the carports. You can use them as canopies as well, but we offer them in kits as well as the standalone base set itself. So the standalone base set will include the structure itself and the racking for mounting panels. Your standard sort of 60 or 120 half-cut cell panel will fit 24, and any of your larger 72 or 144 half-cut cell panels will fit 18. In addition to just the base set, we offer kits that include the modules, the inverters, energy storage, car chargers, as well as some sort of cosmetic features that I'll talk about in a second. So some of the cosmetic features I was talking about here, solar lights for mounting on the piers to provide some lighting when pulling in, a T-gasket for sealing the top face to make sure that it's a completely sealed surface so that water's not coming through down onto the cars or you as you're standing underneath. A mesh sail that goes underneath the system array that allows for sort of covering of the wiring and sort of backside of the panels to provide a more aesthetic look. And then the NLX car chargers to provide just a little bit more value. Next up, just for installers out there, we do have a authorized installer program. Pretty simple process. You fill out the application, you install 3 carports, and then sign the SPA program document. And once you finish those 3 initial installations, you'll receive $1,000 back for each of those 3 carports. And then after that, the program offers $1,000 per carport rebate if you're meeting the 5 carport per month threshold. Although pretty flexible as this is a newer product. So as customers are sort of getting up to speed, there are options for doing a smaller rebate for fewer carports on a case-by-case basis. So we're happy to discuss that and talk about it. And then jumping forward again here, something just that I talked about a little bit earlier, but it allows you some flexibility in terms of designing systems, including our carport system, is the solar kit guide. So as you can see here, basically just ask a few questions as you're going through about what sort of system you would like, gives you the option to choose from different panels that we have available at that time. The roof interface, so like flat roof, carport, ground mount, tilted, sort of any of the options. So you can see there's the carport that we're talking about. On the left, you'll see as it's going through, it's giving you a full bill of materials. And if you actually log into your account, you'll get pricing pulled up on there as you're running through as well. So pretty seamless system that allows you to get a really quick bill of materials with cost for a project in, as little as 5 minutes. Cool. So that's my part there. So I'm just going to jump forward here, and then if it wants to let me. Sorry. There we go. And then now go ahead and jump into the questions if we want to now, Jay.
Okay, thank you. Appreciate it, Nick. So I'm just going to go right off of the Q&A list here in order that they were received. One question from Musa Yusuf is it necessary to do cloud reporting? Will the system function without it? Yes, it is necessary to do cloud reporting only for warranty requirements. In order to update firmware as firmware requirements, may dictate, a cloud connection is required to do those firmware updates, as well as for battery performance data in order to track, the use of the batteries, within the warranty guidelines. But yes, the system will function without it. And it will, so say, for example, if you lose internet connection for a period of time, it will backlog, it will store data for a short period of time, and then will upload it when you, renew that cloud connection. I think it'll store up to a few months worth of data if the Wi-Fi is lost. So it's not required to work, but it is required to be available for servicing of the warranty. So hopefully that answers that question. Yusuf, Musa, thank you very much for that. Let us know if you have any other questions. Another attendee asked or mentioned that I thought Enphase and other microinverters can respond to phase shift commands and be scaled back to the 5 kW limit for off-grid AC coupled PV systems. yes, while it is true that the frequency watt functionality of the battery can be used to, vary the phase, the frequency, and that PV inverters will respond accordingly. But the response and how much they will derate is, I may have to get back to you on this, but I believe it's proprietary, like how much they will derate and how fast they will derate. I know that there is a frequency watt functionality that is has been implemented to a lot of the interconnection, the Rule 21 standards and stuff like that. But I'm not aware of us implementing frequency watt to derate PV yet, though. But we do use frequency shift power control to totally curtail PV in off-grid mode, so that if the battery is at a high SOC, that is what we use to curtail PV completely. But we don't do like smaller phase shifts to derate. Just not aware of us doing that yet. So thank you for that. I know it may not be very clear, but no, it's not available is the bottom line for that. But yes, we do frequency shift for power control for 100% curtailment. So from, hopefully I don't butcher your name too bad, but Vignesh Ramasamy, sorry if I mispronounced that, but your question is, between AC and DC coupled systems, which one is predominantly installed in the market today? Does AC systems cost more because of the additional PV inverter? Well, yes, that's sort of a two-part question. If you're selling, there are pros and cons to both AC and DC coupled systems. I think the primary benefit on the AC coupled system, as far as the dual conversion losses, the efficiency percentage is in the single digits in terms of like the additional losses on dual conversion. So that's really minimal. And when it comes to dollars and cents, and you're talking about cost here, if you're looking at retrofitting a battery storage solution to an existing PV customer, you're talking about having to replace that PV inverter anyways, and basically the loss of that PV inverter as a resource and or as a usable component. And as far as having a single point of failure, a DC coupled system, if that inverter goes down, you not only lose your energy storage capabilities and backup capabilities, but you also lose your grid tied PV generation benefits as well. So AC coupled systems offer you a little bit more flexibility, and in terms of not having that single point of failure, as well as ease of integration to existing PV systems. So AC coupled has got some benefits. DC coupled solutions have that slightly higher round trip efficiency percentage, but again, it's sort of give and take between that and the single point of failure, and additional costs during installation. Let's see. Enphase has frequency shift power curtailment to reduce power output. True. Yes, that's frequency watt is one of the. It's available in I think pretty much every grid tied inverter as a part of IEEE requirements. Thank you, Frank. Robert Mellon, where are the raw materials for your lithium-ion battery sourced from? I don't know. The lithium-ion battery modules themselves, we have two different suppliers. One is for the Evolve ESS, the NMC-based product is from LG Chem. It's the same battery modules that are used in the Chevy Volt, the Bolt, and all of that are the same cells that are used, not the same modules. And the Evolve LFP, the LFP modules are manufactured by a company called Pylon Tech. Not sure where they source their raw materials from. It's a good answer, and we'll have to get back to you on that. I'll leave it to our sales channels to get back to Nick. I'll forward that question, but thank you for that, and it's a good question. Let me see. Raw materials. All right, so we'll have to get back to you on that one. Next question from John Riesbeck. Can this be commissioned without a web connection? If by web connection, you mean without having internet at all, it's possible, but rather than tell you how it can be commissioned without an internet connection, I think more importantly, I think I'd refer back to the earlier question where the participant had asked if that web connection was required for operation. And again, the answer is that cloud connection is required in order to maintain the warranty terms. And that's for updating firmware when necessary, and also for monitoring for battery usage to make sure that it's within the battery module warranty terms. So that hopefully answers your question, John. Thank you. Next question from Vern Sproat. If the grid is down and the battery full, minimal load and sun, is there a back off of power generation function? It sounded like there was a SolarEdge feedback loop, but not for, say, Enphase IQ7 microinverters. No. So to clarify, thanks for asking that question, Vern, actually. To clarify what I was talking about the SolarEdge control loop through their power reduction interface is only to reduce the nameplate rating from, for example, 7,600 watts down to 5 kW for when we go to off-grid mode. So it'll still be producing at 5 kW, and just as the Enphase system, for example, if you have two strings of IQ7 micros that are close to 6 kW, I think maybe 20 panels is close to 6 kW, maybe 5,800 watts on the IQ7s. For any type of PV inverter, within the 5 kW range, when in backup mode at high SOC and minimal load and still effective production situation, that PV has to be curtailed. And so we do have a frequency shift power control where we do a shift outside of the frequency watt derating range and straight to the fast trip range. So as long as the PV inverter that you're using is a current approved by IEEE PV inverter with the frequency trip settings in there, I think it's 62.5 is what we shift up to. So if that inverter does disconnect at a high frequency, that's what we use. We will do a frequency shift at the higher SOCs as our charge rating for the battery system decreases. We slowly ramp up the frequency so that we can continue to serve loads without that trip of the battery, but using that frequency shift are able to curtail PV by going up to 62.5. So that works with SolarEdge, SMA, Enphase, ABB, whatever, any kind of PV inverter. Thanks for that question, Vern. Another question from Musa Yusuf. Are the products available in 50 Hertz? We do have our battery products available in 50 Hertz for, I believe it's the Australian market, single phase 50 hertz. So 50 hertz is an option. I don't know for the North America product. We'd have to get back to you on the details of that. But yes, our inverters do operate at 50 hertz and single phase. So just not the standard evolved product for North America. So if you have more specific questions, please get with the RENVU folks and we'll get your needs met. Thank you for that question. Nicholas Terpstra, what manufacturer makes the inverters used in your units? Actually, the inverter that we use is an Iguana design. Iguana started off, I think, a little over 20 years as, and for the majority of its existence, has operated as a white label power electronics manufacturer, and was selected by a couple of large companies for their systems. We provided inverters to other companies in the past, and I think about 5 or 6 years ago, transitioned to being a system integrator and took those inverters and integrated them into the system that you see here today. So those are our inverters. Thanks for your question, Nicholas. Looks like that's the end of the list of questions here.
Yeah, I think that's all of them on our end. So yeah, just want to thank everybody for attending, and thank you, Jay, for coming. It was a great presentation, a lot of fantastic information, and yeah, if anybody else has any questions, contact info's listed up right there, and should be able to reach out to us, and we'll be able to answer any questions. Other than that, thanks again to everybody, and yeah, we appreciate it.
Thank you. Appreciate it. Take care.